Hello class, we're going to work into our last section here in chapter 11, so this will be the ending of 10 and 11 here, on gravity and force, and looking at a little bit at Newton's laws at this point as well. So first we're going to look at what gravity is. All objects in the universe have gravity. Larger objects have more gravitational pull than small objects. So if we take a look at this picture here, the Earth is a larger object than the Moon, so the Moon orbits the Earth due to Earth's gravitational pull. So what we're going to look at is calculating gravitational force. And when we talk about gravitational force and calculating it, we're actually calculating weight. But when we're calculating it in science terms, we generally will put it in a force term of newtons. However, you can calculate it in pounds or kilograms, something like that as well. So the gravitational force of an object is proportional to its mass. So our equation here is force, or gravitational force, is equal to mass times gravity, or the pull of gravity. And this often in our book, when we look at Newton's second law, it's actually force is equal to mass times acceleration. So this is actually acceleration due to gravity. And that number is a constant. 9.8 meters per second squared. And that's just a constant number. You'll take the mass of the object, whatever that object is, and multiply it times 9.8, and that will give you the force due to gravity. So when we're looking at Newton's second law, and if you take a look at these pictures, you're going to see some force diagrams here as well. Newton's second law says that an unbalanced force acting on an object causes that object to change speed or direction. So when you put a force on an object, you are causing it to, if you give an unbalanced force on an object, you are causing it to change speed or direction. So that's our velocity. We're changing velocity. In the picture up above here, we can see that these two individuals are pushing this individual in a cart, and so our normal force is here, our gravitational force is here, but this is an unbalanced force, so there's acceleration happening, and we have this force that is greater than the force of friction. So you can see all of these arrows are showing the forces that are acting on that object, and we're looking at, is this object able to move based on overcoming friction and all these other forces. The force of the two girls is able to overcome all of those other forces and be able to push the object. In this bottom one, each force acting on the system adds to produce a net force. In this one, we have one individual trying to push, and in this one, she is able to push. You can see this greater force, and it's overcoming the force of friction. You can see that's a small force. Weight and normal forces are equal here, and so this object is accelerating. You can see in the free body diagram over here how that works as well. You can see the forces added up together allow that object to move compared to the weight and normal force and the force of friction. Same thing here, showing how those work together. We are going to be working on some of those in class. Okay, if we change that equation around, acceleration is equal to force over mass. So if we want to take this triangle way to figure out our equations and how to rearrange them, force is equal to mass times acceleration. So force will be here, mass, and acceleration. Okay, and the last part of this chapter and what we're covering is action-reaction. So every action has an equal and opposite reaction. An example here is our balloon. If you blow up a balloon and then you release it, the air rushes down, and so the balloon goes up. So action-reaction. One action will cause a reaction force. Example here, the truck hits the sign, therefore the sign hits the truck with an equal force in the opposite direction, stopping the truck. We will do some of these with balloon cars in class. We are going to be setting up some lab stuff with this as well, and kind of looking at Newton's third law. So for every action, there is an equal and opposite reaction. That will be the end of our notes for chapters 10 and 11. We will do a review video before our test, which is planned for the 14th.